In the heart of the majestic Andes Mountains of South America, humanity is engaged in a direct confrontation with some of the harshest terrain on the planet. Here, engineers are doing the unthinkable, splitting sheer cliffs to build massive roads under conditions so extreme that even the smallest mistake can send an entire project sliding straight into ravines hundreds of meters deep. Imagine working at elevations of 3,000 to 4,500 meters, where the air is so thin that labor efficiency drops by a staggering 30 to 40%, where the weather can shift from intense, skin-scorching sunlight to heavy snowfall within just a few hours. Are you curious how human intelligence can force a road to cling to near vertical cliffs that have isolated regions for centuries? Join us as we uncover the secrets behind this engineering marvel. Building in these mountains is not just a test of grit, it is a financial and technical gamble. In these projects, more than 60% of the total cost is not spent on the road surface itself. Instead, that money goes into rock excavation, slope stabilization, and landslide prevention. To survive this environment, engineers follow a strict two-stage strategy. The first stage follows the outer cliff face, where the road is cut directly into the mountain and stabilized with anchors and retaining structures. But when the terrain becomes too unstable or steep, even for anchors, construction shifts to the second, more complex stage, tunneling deep through the mountain heart to bypass the most challenging sections. The process begins with absolute precision. Before any rock is moved, engineers determine the road's center line and mark construction boundaries directly onto the rock face. Based on this layout, drill holes are arranged according to millimeter-level calculations. The charges are carefully loaded in controlled amounts to ensure that while the rock breaks in sections, the overall stability of the mountain remains uncompromised. After each controlled rock removal operation, once the rock has been loosened, massive excavators weighing hundreds of tons move in. They pick up and remove fragmented soil and stone, clearing the construction surface for heavy-duty trucks positioned precariously along the edge of the road. In sections where the terrain allows, bulldozers push material directly down into the rivers or steep slopes below to speed up clearance. Then, the real shaping begins. Bulldozers carve the mountainside into the initial roadbed, with blades constantly adjusting to achieve the exact slope and elevation required. Once the surface is graded, graded aggregate or crushed stone is delivered in strips. Motor graders spread the material into uniform layers, adjusting it precisely to design profiles. But there is a secret to the stability: moisture. Water trucks spray the surface to control dust and create the perfect conditions for compaction. Then vibratory rollers move in multiple overlapping passes to achieve the specified density, ensuring the roadbed will never settle under the weight of future traffic. But what happens when the cliff is almost vertical and there is no space left to cut into the mountain? This is where we see the peak of engineering innovation. The road must be suspended. Instead of excavating deeper, engineers build large reinforced concrete columns directly onto the bedrock. These act as a structural skeleton. Because traditional vehicles cannot reach these heights, materials are lowered from above using cranes or specialized transport equipment. The road deck modules are then installed section by section, much like assembling giant building blocks on a mountainside. Each module is prefabricated with steel girders and concrete slabs, significantly reducing on-site construction time and keeping workers safe. When these modules are locked onto the columns, they form a continuous ribbon that follows the natural contours of the mountain. When the surface becomes too challenging, engineers go underground. They use a tunnel boring machine, a 3,000-ton steel giant stretching nearly 100 meters long. To keep it running at depths where air can become toxic in minutes, vertical ventilation shafts are drilled up to 200 meters high using the raise boring technique. At the front, 4 massive hydraulic cylinders press a 15-meter diameter cutter head against the rock with 500 tons of force. 23 alloy discs spin with immense torque, crushing layers of rock as hard as steel. This rhythm repeats 24 hours a day until the mountain is conquered. As the machine advances, workers behind it install concrete lining segments, forming smooth circular tunnel walls. The tunnel is built and finished simultaneously. From the control cabin deep inside the mountain, operators command thousands of mechanical systems working in perfect harmony to push through the solid rock. Once the asphalt is sprayed, a thin coat of liquid asphalt heated to activate its bonding properties, the road is finally complete. From above, it looks like a black ribbon draped across the cliff face, a symbol of precision and human resilience. These roads do more than move vehicles. They reconnect people isolated for centuries. They are a testament to how technology and perseverance can turn impossible terrain into a path for the future. If you found this engineering journey fascinating, leave a comment and subscribe. We will see you in the next epic story of human innovation.